I'm glad to see everyone made it to school safely this morning. I wish I could say the same for myself, but I had a rather close call when I was getting on the expressway. I was on the on ramp and my car suddenly skipped and turned completely around. So I ended up with my car facing backwards. Luckily, there was no one right behind me. I was able to turn my car around and slowly drive on. You see, what had happened was I ran into a patch of black ice. And the nature of black ice is that you just don't see it coming because it's practically invisible. Generally, the formation of ice requires two conditions. The presence of water and temperatures below freezing. However, black ice can form on the highway when the air temperature is slightly above freezing but the ground temperature is below freezing. That's how it was at 7 o'clock this morning when I was driving to campus. The air temperature was 34 degrees Fahrenheit. However, the overnight low had been in the low 20s. So the ground temperature was below freezing. The black ice formed when evaporation on the wet surface of the pavement. It was mist actually. Water vapor when the mist was exposed to above freezing air temperature. The evaporation lowered the surface temperature to below freezing. And this then froze a very thin layer of mist on the surface of the pavement. Excuse me, Dr. West, I'm not sure I heard you correctly. Are you saying it's possible for ice to form even when it's not freezing outside? Yes, and black ice is a good example of this. The air temperature can be above freezing, but the temperature of a wet surface like pavement can be lower. The same thing happens when wet laundry is left hanging outside and it freezes solid at an air temperature of 35 degrees. Water evaporates from the wet crosses, which are colder than the air, and the vapor rising from the laundry freezes. So your crosses are then covered with a thin film of ice. One of the reasons black ice takes us too much by surprise is that we don't expect to find ice when the thermometer says it's above freezing. The air temperature, that is. But air temperature can be deceiving and we have to be careful, especially on a morning like today. We usually think of ice formation as the freezing of liquid water, but ice can also form by the process of sublimation. Sublimation is when water changes states from a gas directly to a solid or from a solid to a gas, without first becoming a liquid. Ice formation in this way, by sublimation, forms directly from water vapor or mist, which is gas. So what we are saying is rock ice is formed by sublimation? Yes. Rock ice is formed by sublimation directly from water vapors on the surface of the rock. Rock ice is a form of frost. Some other forms of frost are ground frost and frost you see on windows on cold winter nights. It can look like delicate feathery patterns of crystal on your window pane, or it can be found like crystal several centimeters long on the twigs and branches of trees. Water vapor forms as a front on the surface of an object if the temperature of the surface falls below both the freezing point and the point at which water vapor condenses to a liquid. In the case of window frost, the temperature of the window glass has to be below freezing. The window is chilled because it's losing heat to the colder air outside. By the way, the beautiful patterns of window frost are due to its slightly curved crystals because of organic impurities on the glass, dust, and dirt that interfere with the crystal growth.